So now we have a better picture of benzene, right, that we call the Kekule benzene or the Kekule form of benzene. And yet we know that, there are issues with it based on its reactivity and based on the bond lengths and angles of it being a perfect hexagon. And so one of the things that Kekule said was, well, maybe there's a resonance of benzene that can that can attribute to the overall shape of it, and not necessarily predicting the reactivity of it, but at least the shape of it. And so he came up with this idea that instead of one type of ring, you actually have a resonance form of two Kekule rings. And so if I take this picture of benzene, right, where I have this alternating double, single bond, and I draw a resonance structure where I essentially move the double bonds to the adjacent carbons, then I get this structure, right? And so at first glance it would appear that they're different, um, and yet what Kekule said was maybe they're in such resonance that you can't distinguish between the two of them, right? So I can think about an orbital picture, not quite a molecular orbital picture, but I can envision that in this resonance structure, right, each carbon is sp2 hybridized, and so each carbon has a p orbital. And those p orbitals are used in creating the pi bonds, right? So what I have is I have a pi bond between these two carbons, and then I have a pi bond between these two carbons, and I have my third pi bond between these two carbons. And so now what happens is you can see that since each carbon is adjacent to another carbon with a p orbital, you could easily move those electrons such that I now have a pi bond between these two, a pi bond between these two, and a pi bond between these two. And they're essentially indistinguishable from one another. One way that we can show this indistinguishability is by taking benzene and actually drawing what we call the circle in the ring, which looks like this, right? So we have the hexagonal shape, and we simply draw the pi electrons, the 6 pi electrons, as a circle within that ring to denote that in reality we don't have an alternating double single bond. Now, you'll see that circle in the ring structure drawn, but oftentimes especially when we're drawing mechanisms, we still use what we call the Kekule form in order for bookkeeping purposes of the electrons.